good morning, everybody at home. Can I get a thumbs up that you hear me and see the board okay? Okay, all right, here we go, guys. We are starting section 6.4. We just finished the section on inverse functions. So the next section that we go to is going to kind of put that into effect in the sense that we spent chapter 5 learning all about exponents and powers. Now we're going to learn about the inverse to an exponent, the inverse to a power. So what's going to undo squaring something? What's going to undo raising something to the third power and whatnot? The inverse to exponents and powers are radicals or roots, all right? So in this section, we're going to be simplifying nth root radicals. And what I mean by nth root is, guys, I need you guys to understand that the square root isn't the only root out there. The square root is how we undo squaring something. But we don't just square things. We cube things, right? We raise things to the third power. We raise things to the fourth power and the fifth power. So we need roots that will undo those powers as well. So there's going to be third root radicals. There's going to be fourth root radicals and fifth root radicals and stuff like that. So that's what they mean when they say nth root. Nth meaning it could be any root. Maybe it's the square root. Maybe it's the third root. Maybe it's the fourth root, okay? So I want you to understand the vocabulary that goes along with all of this first. So when you're dealing with radicals and roots, well, guys, the square root symbol, it's not really a square root symbol. It's a radical with a root of 2. So this symbol right here is called the radical symbol. This number right here is called the index, which is also known as the root. It's telling you what root you are taking of the number underneath. All right, what power are you undoing? So if it's a third root, you are undoing a third power. All right, and then whatever you're taking the radical of, the number underneath is called the radicand. So if you ever see that vocabulary, that's what it's talking about. We have the radical symbol, we have the index or the root, and then we have the radicand, the number underneath, all right? And the index is the most important part because the index n, it indicates what root of that radicand you are taking. What power are you trying to undo, okay? So with nth roots, it's going to look like this, but n will be replaced with a number that will represent the index or the root. All right, so guys, if n is 2, then it's the square root symbol. It's the one you guys know. If it's the nth root and n is 2, it's the square root. However, I hope you guys realize that the square root symbol didn't have a number there, didn't have an index showing. That's because there is no first root. We don't take the first root because really that's just the number itself. All right? But if there's no number written there, it's assumed to be 2. So when there's no number written as the index, it's assumed to be an index or a root of 2. All right? And then think about what it means. If you take the square root of 36, what you're really trying to do is you're trying to unsquare it. What number times itself 2 times equals 36? So guys, does anybody know what number can you times by itself 2 times to equal 36? 6. So the square root of 36, the answer is 6, okay? You're unsquaring it. You're untimesing it by itself 2 times. All right, well, what if the root is 3? If n is 3, then it's going to be the third root of a number. So then it'll look like this. I know it's blurry. It's the third root of 8. When you take the third root of 8, you're trying to unthird power the 8. So you're really trying to find out what number times itself 3 times equals 8. So does anybody know what number you could multiply by itself 3 times and it would equal 8? It's 2. 2 times 2 times 2. So 2 to the third power is 8, right? So the third root of 8, guys, it's 2. Because 2 to the third is 8, right? So when you take the third root of 2 to the third root and the 3 cancel out because remember 2 to the third is 8 and you're just left with the 2. You're unthird powering something. All right, and then the last one, if n is 4, then it's going to be the fourth root of a number. So if I took the fourth root of 81, you're trying to unfourth power the 81. So you're trying to find out what times itself 4 times equaled the 81. Does anybody know what number times itself 4 times equals 81? Just a little bit bigger than 2. 3. So it would be 3 times 3 times 3 times 3. It would be 3 to the 4th power is 81. So the 4th root of 3 to the 4th is 3. So the answer to this problem is 3. That's the number you have to times by itself 4 times to get 81. All right, so that's what roots and powers are going to be like. The roots are going to undo whatever power was on that number, okay? All right, let me move mine up. Okay. BB3. Hey, Kim. Oh, yeah, she is off this period. She'll be back. She sits in here. She just went down the hall real quick. Can I have her call you when she gets back? Oh, we're at 10. Oh, I'll tell her. Oh. We didn't have any this year for pre-cap. So I have no idea, actually. All right. All right, bye. Okay, well, the good news is, so you're probably the most comfortable with square roots. It's definitely the root that you have seen and used the most, right? Most. Before we get into all these 3rd roots and 5th roots and 6th roots and all these other roots, guys, I need you to learn a little bit more about the square root. So we're still going to be working with the square root today before we move on to the other roots, okay? All right, so guys, let's review some square root stuff. How do we simplify square roots? Well, guys, remember, every time you don't see an index, it's assumed to be 2. There is no first root. If there's no index, it's a square root. All right, so guys, what's the square root of 49? What number can you times by itself twice to get 49? It's 7, right? So we know the answer to this is 7. Those are the easy ones, right? They're going to throw a perfect square under a square root. It's very easy to unsquare. All right, what about 75? Can you think of a number that you can times by itself 2 times to equal 75? Well, 8 squared is 64, and 9 squared is 81. We went past the 75, which means he's not a perfect square. But guys, we've been doing this for a while now. We simplify square roots, right? Does anybody know the biggest perfect square, the biggest number you can take a square root of that divides evenly into 75? 25. So we would break it up into the square root of 25 times the square root of 3, right? So if it's not a perfect square, you always had that leftover number still stuck under the radical. So remember that. That's normal. All right, and then the square root of 25 is 5, and then the square root of 3 stays, because he's not a perfect square, and he can't be simplified anymore. All right, and then we even got into the ones where you got to take the square root of a negative number. Now, guys, remember, were we technically allowed to take the square root of a negative number and get a real number answer? No, because nothing squared, nothing times itself twice should end up equaling a negative number. So we know the answer to this was imaginary. So the first thing we did is we pulled out that factor of -1, and then we gave ourselves a positive 24. And does anybody remember who the square root of -1 actually was? He's not real, he's the imaginary number I, and then we went and we simplified the square root of 24. Who's the biggest perfect square that divides evenly into 24? It was 4, and then times 6. And then we would keep simplifying. It's going to be I times, who is the square root of 4? That was 2. And then the square root of 6, he's our leftover. He is a number we cannot take the square root of, and no perfect squares divide evenly into, so he stays and he's stuck under the radical. And then we just kind of rewrote it in a better way. I times 2 is 2 times I times the square root of 6. So we've done all that this year with square roots. So all of that should be hopefully a review. Well, what I need you guys to learn now is, what if they want you to take the square root of a variable? How do we take the square root of some unknown value, okay? Well, guys, it's going to go all back to, remember that a square root is undoing something that is squared. That's going to be the key to doing the square root of a variable. So, guys, if I asked you, what's the square root of x squared, right? I'm technically asking you, what times itself 2 times ends up equaling x squared? What times what is x squared? X times x, exactly. So the answer to this is definitely x. And guys, think about it. In reality, what's happening is this square root is the inverse to that square. They undo each other. So this square root and that square are canceling each other out, and it's leaving you with the x. So what you want to remember is, when you're taking the square root of a variable, every time you can make an x squared underneath a square root, you're going to be able to unsquare that. So for each x squared that you square root, you will create yourself an x. If you can create an x squared to unsquare, we know the answer to that is x. You want your root and your power to cancel each other out. And the only way they'll cancel is if the root and the power are the same. We need to take the square root of a square, okay? All right, so look here. I'm going to try and not move this up right now. Simplify the following square roots. I have to say this, assume all variables are positive. Otherwise, we get into a little bit of a hairy situation. If we're taking the square root of a negative number, it would be imaginary. So I don't want to have to get into that with the whole imaginary and not imaginary. So we're just going to assume that everything under it is positive. So we don't have to worry about anything being imaginary, okay? All right, well guys, let's say I asked you to take the square root of x to the fourth. I'm taking the square root of something raised to a power of 4. So my root and my power don't match up. So in reality, what you have to do is you have to think about, all right, for every x squared that lives inside of x to the fourth, I can square root. So you have to figure out how many x squareds can you make from x to the fourth. Well, guys, isn't x to the fourth technically x squared times x squared? Don't you add your exponents when you're multiplying? Yeah. Somebody... Oh, thank you, Marquita. I appreciate that. All right, so we're going to rewrite x to the fourth as x squared times x squared because that's the same thing. But what I've done is I've created square rooting x squareds. So now I can think about this individually. The square root of x squared times the square root of x squared. And now who's the square root of x squared? X. Who's the square root of x squared? X. And then your answer is just going to be, what's x times x? X times x is x squared. So the square root of x to the fourth is x squared. All right, so think about that. Every x squared that lives inside of x to the fourth, we're going to be able to get an x from. We're going to be able to unsquare that. All right, so let's look at this one. The square root of x to the sixth, right? So how many x squareds can you make out of x to the sixth? Well, isn't that going to be x squared times x squared times x squared, right? Add your exponents. 2 plus 2 plus 2 is 6. So now I've created all of these x squareds. Now you can square root all of them. And every time you square root x squared, you get an x. So this will be x, this will be x, and this will be x. Now my answer will be, what's x times x times x? X to the third. All right, so the square root of x to the sixth is x to the third. Now, guys, there's going to be a shortcut to this, all right? I don't know if you see it yet. I'm going to do one more the long way. If you have to take the square root of x to the eighth, how many x squareds can you make from x to the eighth? Let's see. It's going to be x squared times x squared. That only gets me x to the fourth, so keep going. Keep giving yourself x squares. All right, that gets me x to the sixth. One more, and now I have x to the eighth. 2 plus 2 plus 2 plus 2. All right, so if we square root all of them, we're going to get all these x's. All right, now the square root of x squared is x. The square root of x squared is x. The square root of x squared is x, and the square root of x squared is x. So the answer to this is x times x times x times x, which is going to be x to the fourth. So the square root of x to the eighth is x to the fourth. That's what you have to times by itself 2 times to get x to the eighth. All right, well, guys, there's a simpler way to do this. It's kind of going back to elementary school. We're trying to find out how many x squareds we can make out of x to the fourth. So you're trying to figure out how many pairs or groups of 2 live inside of 4. That's division. If you want to know how many groups of 2 you can make out of 4, it's division. Take 4, you're trying to make groups of 2, right? Divide it by 2. What's 4 divided by 2? It's 2. It's x squared. How many x squareds or groups of 2 can you make out of 6? What's 6 divided by 2? It's 3. It's x to the third. All right? If I want to know how many groups of 2 I can make from 8, divide it. 8 divided by 2? It's 4. So the easier way, the quicker way, is take your power and divide it by your root, and that'll leave you with your answer. All right? So go down to this. Oh, why did I do that again? All right, so guys, you don't have to write this down if you don't want to. But to take the square root of x to the 10th, we would try to figure out how many x squareds we get, right? So x squared times x squared gets me 4, times x squared gets me 6, times x squared gets me 8, times another x squared gets me 10, right? So that's how many x squareds I can make from x to the 10th. I would square root all of them. I would get x times x times x times x times x. And I would end up with x to the 5th power. Done. The easier way to do this, to figure out if I'm square rooting something, to figure out how many groups of 2 I can make from 10, is to rewrite it as x to the take your power and see how many groups of 2 you can make. Divide it by 2, and what do you get? You get x to the 5th, which is a much easier way to get that answer than to sit there and figure out, all right, how many x squareds can I write that I can square root? So the quicker way to get to this answer is take your power and divide it by your root. Power over root. Okay? And I always remember it as, where do roots live? Roots live under the ground, right? So root is always your bottom number underneath the fraction, okay? All right, so guys, if I asked you, what is the square root of x to the 14th? How many pairs of 2 can you make out of x to the 14th? The easiest way to do that is make it x to the power divided by root. And what's 14 divided by 2? 7. So the answer to this is x to the 7th. So take your power and divide it by your root. All right, you guys tell me right now, what is the square root of x to the 20th going to be? And so
I have a question.
Go ahead, Cam.
What does it say on the second problem?
Here?
Yeah.
I put a 2 there to remind us this is the square root, that's the index. And then it becomes x to the power 10 divided by the root 2. So that's 10 divided by 2, which will get us x to the 5th power. And then I wrote, you take your power and you divide it by your root. That's the shortcut.
All right, thank you. I couldn't see it.
Yep, I'm sorry about that. All right, so somebody said it. This one should be x to the 10th, right? It's the square root of x to the 20th. So that's going to be x to the, how many pairs of 2 can I make from 20? It's going to be my power 20 divided by my root 2, and I'm going to get x to the 10th. Done. Okay. So guys, hopefully that feels easy and you're like, all right, no big deal. So if I take the square root of a variable, I just have to take his exponent and divide it by 2 and he'll break free from the radical. Perfect. But there's a problem. Let me move my notes up. The problem is, if we're going to be taking all of these exponents and dividing them by the root, what happens if the power or exponent does not divide by that root? Guys, does 13 divide by 2? No. So what if you were taking the square root of x to the 13th? We don't want to create some decimal exponent. So what happens is, if you can't take the power and divide it evenly by the root, it just means there's going to be a leftover variable stuck under the radical. You're not going to be able to break all of that variable out of the radical. So guys, watch this. I'm going to do it the long way, and then we'll do it the short way. What if I asked you to take the square root of x to the 7th? Does everybody agree? The shortcut would say, okay, that's going to be x to the, take your power 7 and divide it by the root 2. But 7 doesn't divide by 2, right? So that's a problem. So what happens is, it just means you're not going to be able to completely get rid of the radical here. You're going to have something that is left over. So think of it like this. Let's go back to the long way. How many x squareds can you make from 7? Well, let's see. X squared times x squared gets me 4. Times x squared gets me 6, right? Do I need another x squared to make 7? No, I only need an x. I only need a power of 1 to make 7. So that means there's a leftover variable that you're not going to be able to make a pair out of, that you're not going to be able to make an x squared out of. So now what happens is, this is going to be the square root of x squared, the square root of x squared, the square root of x squared, but he's just going to be the square root of x. So now you're going to get x times x, right? All of these cancel and go away, but he's stuck. He has to forever stay underneath that radical. So what's going to happen is, you're going to say, all right, I get x times x times x on the outside, not under a radical anymore. That's x to the third. And then the square root of x has to stay. So you're going to have leftover variables underneath the radical still if the power doesn't divide evenly by the root. Okay, so what I would do this, the short way, is I would do this. I know I want to take my power and divide it by the root, right? So I would rewrite x to the 7th. Guys, what's the closest number to 7 that does divide by 2? 6. So I would break it up into x to the 6th times, now I need 1 x left over. Isn't 6 plus 1 an exponent of 7? So you're going to break the number up underneath. You're going to get as close to that number that will divide by that root as possible. So now I'll just break it up into the square root of x to the 6th times the square root of x. And now, guys, what's the square root of x to the 6th? That's going to be 6 divided by 2 is x to the third, and then the square root of x stays. So the easier way to do this, the quicker way, is just break up the number underneath to the closest power that will divide by the root. All right, so guys, look at x to the, what did I put? Oh, guys, change this to a, let's do 19. I should not have done 18, so that's my bad. All right, what if this was the square root of x to the 19th, right? This would be equal to x to the power divided by the root. Does 19 divide by 2? No. So what you want to do is, guys, what's the closest number to 19 that will divide by 2? 18. So let's break it up into the square root of 18 times the square root of how many x's are left over? Just 1, right? 18 plus 1 gets me 19. So now I can break this up into the square root of x to the 18th times the square root of just x. So guys, what's the square root of x to the 18th? What is 18 divided by 2? 9. So he's x to the 9th, he's free. The power divided by the root, he's free, no more radical. But can I take the square root of a just x? No, he's the leftover part. He stays the square root of x. So to simplify the square root of x to the 19th, it simplifies to x to the 9th times the square root of x. So guys, if your power doesn't divide by your root, you're going to have a leftover variable that you can't get out from underneath the radical. All right, what about the square root of x to the 13th? We'd love for it to be x to the 13 power divided by root. Does 13 divide by 2? No, right? Okay, so then we got to break this up. What's the closest number to 13 without going over that does divide by 2? 12. So let's rewrite this as the square root of x to the 12th times how many x's are left over? 1, right? Because 12 plus 1 makes 13. So now we can split it. This will be the square root of x to the 12th. That'll be our good guy, the one that does divide by the root. And this will be the leftover. All right, so now if we take the square root of x to the 12th, it's going to be x to the, what's 12 divided by 2? 6. He's free. He divided, he's free. Can I take the square root of a just x? No. So he's the leftover part, and he'll be the one stuck under the radical. So just like when we simplify square roots, like the square root of 75, it was 5 times the square root of 3. Something was stuck under that radical. So if it's not going to divide, you are going to have something stuck underneath that radical. All right, I'm going to give you guys one to end on, and then we'll stop there. What's the square root of x to the 15th? Double check your answer with mine, right? 15 does not divide by the root of 2, so we're going to split it. The closest number was 14 with 1 left over. So then 14 divided by 2, that's x to the 7th. He's free. And then the square root of x is left. You guys get that? Okay. All right, at home, thumbs up if you're okay. All right, so here's the deal. Believe it or not, that's really just the tip of the iceberg with the problems that you're going to be assigned. So I just kind of wanted to ease you into this because I'm not sure you've ever seen this before with the variables under square roots and stuff. So I didn't assign any homework for tonight. So tomorrow we have an assembly, guys, for you guys in class. Guys, we actually have like an assembly the second half of the day, periods 5 to 7, I believe, that the whole school is going to. So I don't know if I'm actually going to assign work tomorrow for you guys because whatever I do with period 2, I'm not going to be able to do with period 6 or 7 because I won't see them. So tomorrow might be a free day. I'll definitely post it on Google Classroom and let you guys know, but I may have to pause and pick this back up on Friday, okay? Because I don't want to get you guys ahead of the other classes. That drives me crazy. All right, so it might be a slow day for you guys tomorrow then too. All right, but just letting you guys know, just check Google Classroom for tomorrow. So your work for tomorrow will be to read over these notes. Keep this fresh so we don't lose it for Friday, most likely, all right? But no homework, and then just check Google Classroom for what our game plan is for tomorrow, okay? Have a wonderful day, guys. Let me know if you need any help or have any questions.